Use basic shapes to evaluate this function. What I have to do is I have to graph it. Whenever you're trying to figure things out like this, you have to graph it, and you'll see why in just a minute. We have a y-intercept of 8 and 1, 2. This is going to 3. My slope is -2, or I can just say when x is 3, y is 2. I start at 8, yes. And at 4, I would go to 0. Pretend that's a straight line. And what we want to do is we literally want to find the area from here, this area, between 1 and 3. Cut the region under the graph into 2 simpler shapes. I don't actually need 2 separate shapes, but I could do, okay, I'll do 2 separate shapes, but this is a trapezoid. I could actually just find the area of a trapezoid. We can do that also, but I'll first do it the way they're saying. So I'm assuming that the 2 shapes they're looking for is this triangle here and the rectangle underneath. The area of the rectangle is going to be the base, which is 3 minus 1, or 2, times the height, which is 2 minus 0, or 2. My rectangle is 4 units of something. And then my triangle is going to equal 1/2 base times height, which is 1/2 times. The base is 3 minus 1, which is 2. When it's 1, it actually is 8 minus 2, which is 6. So this would be times 6 minus 2, and that would actually be correct. It would be 4. My rectangle and my triangle actually have the same area. Okay. And the total area here, total area would be 8. Or if you can see the trapezoid, so I'll draw just the trapezoid part. Here's what this trapezoid looks like. And the formula for a trapezoid is 1/2 B1 plus B2. So basically it's the average of the top and bottom times the height. But my base 1 and my base 2 have to be parallel to each other. So actually this is, we can call this B1, we can call this B2, and we can call this length H. Let's see if we come up with the same answer. I'm actually kind of curious myself. Let's see, we have 1/2. B1 is going to be from 0 to 6. Plus B2 is going to go from 0 to 2. This is base 1. This is base 2, the blue. And then that's going to 2. And I'm going to multiply by the height, but here the height is actually the width, which is 3 minus 1, which is 2. And I get 8, which is awesome because that's what I was supposed to get. That cancels with this. This equals 8. And so the area of the trapezoid is 8, which matches the area if I break it into 2 pieces. And now we're going to evaluate the same function using the fundamental theorem of calculus. There's 2 fundamental theorems of calculus. The one we're using for this is the one where we plug in the values, along with the power rule, the sum rule, and the constant multiply rule for antiderivatives. We've used all these before. We can say the integral from 1 to 3 of 8. This is the sum rule of 2x dx. And the constant multiplier rule basically is the rule where we take the constants outside of the integral. Two times x dx. And this equals 8x between 1 and 3 minus 2 times x squared over 2. X to the 1 power, add 1, divide by that n plus 1. And that is between 1 and 3 as well. I plug in my top number. So first, here, I'll do this first. So I plug in 3, I get 24. I subtract when I plug in 1, which is 8. I'm going to subtract the second piece. I can cancel this 2 with this 2. And really all I have now is x squared. 3 squared is 9 minus 1 squared is 1. And this whole thing equals 24 minus 8 is 16 minus 8, which is 8, which is what we keep getting for this. So we got that here and we got that above. Check, check.